All right, college algebra, this is for all of you that are on the New York trip and whatnot. Um, there's two parts, so we're going to do one part that's just inequalities, and then the other part will be word problems. For the word problem part, you will definitely want to have a calculator out, so just be mindful of that. This is your homework from last night, the answers. So feel free to pause the video as I kind of click through the screens if you want to check your work and make sure you really know what you're doing. All right, so here's 39. Here's 41, 43. Oh, you got a worksheet as well. So this is the first page of the worksheet. Please notice on number 3, I didn't have enough information to start with, and so I did need a point, and that's where this comes down into play right there. That's how I found this point down low, okay? And then the back side of the worksheet, the back side did require on number 6 for you to do long division. So things to keep in mind there. All right, we already did once by equation. So we're going to work on solving rational inequalities. So basically fractional inequalities. And I'm going to take two approaches to this to start with. I'm going to show you how to graph things and interpret what's going on. And then I'm also going to show you something called interval notation. All right, so where does 2x minus 1 over x, where is it positive? Now, normally, this would be a function where this would be equal to y. And what I want you to understand is I'm asking for where is this positive? Where are the y values bigger than or equal to 0? All right? So just keep this in mind. Where are y values 0 or positive? Okay? So here I go. If we did a graph of this, I would find the x-intercepts. Remember, that's your numerator, right? That's up here. So what are my x-intercepts? 1/2, comma 0. My y-intercept, well, I'd take this whole thing and I'd say when x equals 0, there is none. Okay? I have a vertical asymptote at x equals 0. I have a horizontal asymptote at, well, that's this part. Where does 2x divided by x, what happens with that? I would get y equals 2. Okay, so a quick sketch of this graph is what we're going for here. And so when I do this, x-intercept at 1/2 looks like that. I have a vertical asymptote at 0. I have a horizontal asymptote at 2. Well, I had poor planning here. So my graph, let's see, on the left-hand side, there's nothing underneath. So this graph actually has to go up here. And then down below, it has to go down there. The question is, where is this graph positive? Where, like, look, y values. I want all of the places where this graph is positive, right? It's y values greater than or equal to 0. So that's this part is totally positive, and this is equal to 0, and this part is positive. So what are the x values associated with that? Well, negative infinity for x values all the way to 0. By the way, nothing's happening at 0. It's an asymptote, so I can't count it. And then I start back up again at 1/2. So I have to do a union. Ooh, it's a square bracket because 1/2 actually equals 0. So square bracket 1/2 to positive infinity. Okay, so that's great and all, but I want to show you a little bit more of a precise way to do these things, or maybe it's more of a efficient way to do things. And it's through intervals. And this is how your book presents it. Okay, so what are my factors? My factors are 2x minus 1 and x. Okay, and down here, I'm going to draw a number line. And on that number line, the important parts are where my factors equal 0. So 2x minus 1 equals 0 at 1/2. That should say 1/2. Let's try that again. And then x equals 0 at 0. So 0 is smaller than 1/2, so we'll put it over to the left. Okay? And we're going to kind of make a chart up. And so in this chart, we're going to have partitions at where our factors equal 0. And then we're going to test numbers, okay? So here we go, 2x minus 1. These are what's going on here. 2x minus 1. If I pick a number like -1 and I plug it in, 2 times -1 minus 1, that equals a -2, or -3, I'm sorry. All right, let's pick a number in the second interval, like a 4th. What is, let's try this again, what is 2 times 1/4 minus 1? Well, 2 times a 4th is 0.5, and 0.5 minus 1 is -1/2. So overall, that value is negative. And let's pick something over here. Let's pick something obnoxious like 10. If I plug in 10 to this factor, what happens? What's 2 times 10 minus 1? It's 19. That's positive overall. Fine. Let's do the same thing for our second factor, for x, down here. Let's plug in -1 again. If I plug in -1, I get -1. That's a negative value. If I plug in 1/4, right? If I just plug in 1/4, x would be a positive number. If I plug in 10, well, 10 is a positive number. Overall, what's going on with this function is that you really have, let's see, clear this up here. You really have 2x minus 1 divided by x. You're dividing things. What's a negative divided by a negative? Well, a negative divided by a negative overall is a positive. Fine. What's a negative divided by a positive? Overall, it's a negative value. What's a positive divided by a positive? Well, it's a positive value. What do we care about? We care about where this function is greater than or equal to 0. So look at this. I have a positive value here. So that's all of these values all the way up to 0. 0 was an asymptote, so it doesn't count. And then this, according to this model, we're negative here. And then at 1/2, that was an actual x-intercept, so that will be equal to 0. And then if we continue on, we said these values over here were positive. So what we have here is a number line that's giving us all of our values. So there's -infinity to 0 with a parentheses around it, because parentheses, the 0 was a vertical asymptote. It was in the denominator. It didn't equal 0. And then I jumped over to 1/2. Now 1/2 is where I actually equaled 0, and I went to positive infinity. Okay, so we're going to try to focus on doing the interval notation for these. Okay, please also look in your book in case you need extra help. Example 2. You've got x squared minus 4 divided by x. And the question on this one is, where is this less than 0? So y values are less than 0. Okay? So again, I'll start off with a graph just to kind of give you guys an idea of what's going on. This is x minus 2 and x plus 2 in the numerator, and we're dividing by x. Okay? So if I go for what are my x-intercepts, my x-intercepts are 2, 0 and -2, 0. My y-intercepts, well, there's y-intercepts. What happens when x turns into 0? It's undefined, so I don't have any y-intercepts. Vertical asymptotes, that's the denominator, and that's where x equals 0, because that's my factor. Okay, and horizontal asymptotes. On my horizontal asymptote, I look at these two things. Ooh, it's bigger degree on the top than on the bottom. So guess what I need to do? Long division. X divided into x squared minus 4. Okay, so x times what is x squared? Well, that's just x. So x times x is x squared, and that's all I got to do. So then I have to subtract, and I have a -4, and yeah, okay, so I'm done. So my remainder is -4 over x, and so my horizontal asymptote is simply just y equals x. So what does that graph look like? Well, here we go. Plotting all my points. I've got x-intercepts at 2 and -2. I've got a vertical asymptote at 0. And then I have a line with a slope of 1 and a y-intercept of 0. And if I graph this thing, let's see. I have to be on the outside, and that's okay. It looks kind of weird. But the blue is what I care about. Okay, so overall, that's the graph of my function. I want to know where are the y values negative, right? Where are the y values less than 0? So there is a 0, but I want all the stuff that's less than 0. And then this is a 0, so I don't want to count that, but I want everything less than 0. So if I overall kind of deal with things here, my x values that are associated with this, I'm going to go from, like, these are my x values, way over here, -infinity to -2. I use parentheses because at -2 I equaled 0. I'm not supposed to equal 0, though. Union, and then it's these x values up here, okay? And that was from 0 to 2, okay? So now I want to verify, excuse me, that my interval notation will give me the same result, okay? So let's look at intervals. And let's see, my factors are x minus 2, x plus 2, and x, okay? Let's create a number line. And let's talk about these intervals, okay? So just looking at the intervals. So at x minus 2, that equals 0 at a positive 2. Okay, I don't want to actually equal that. So I'm going to put an open circle there to start with. I think that'll be a better way to handle it because that's where I equal 0. So it's a boundary, but I don't want to actually equal that. At x plus 2, that equals 0 at -2. And again, that's a boundary point, and I don't want to equal 0, so I'm going to make an open circle. And then in between, x equals 0 at 0. And that was a vertical asymptote. That's in the denominator, so I'm not allowed to equal that no matter what. Okay, so we're going to partition this off. That's kind of how this works out. So I actually have a total of 4 different sections. 1, 2, 3, and 4. And I have to test values in all 4 sections and see kind of what's going on. Okay? So let's pick a number like -3. -3 is going to be my test point. If I plug in a -3 here, -3 minus 2 is -5. Overall, that's a negative answer. Let's pick something between -2 and 0, like -1. If I plug in a -1 here, -1 minus 2 is -3. So overall, that value is negative. And then I'm going to pick a positive 1 because that's a number that's in the third interval. If I plug a 1 in here, I have 1 minus 2, which is still overall negative. And let's pick a positive 3 in that fourth interval. 3 minus 1 is 1, so that's positive. Fantastic. Moving on, let's choose these exact same green numbers that I've got down low and put them in the x plus 2 factor. -3 plus 2 is a -1. -1 plus 2 is positive. And then if I plug in a positive 1 plus 2, that's positive. And then 3 plus 2, that's positive. Fantastic. Last factor, x. If I plug in a -3, you get negative. If I plug in a -1 here, I get a negative. If I plug in positive 1, I get positive. If I plug in positive 3, I get positive. All right, so that's your chart. And then the question overall is what's going on? A negative times a negative divided by a negative. If you get 3 negatives, overall your answer here is negative. A negative times a positive divided by a negative is overall positive because you've got 2 negatives. 2 negatives multiplied and divided together will give you a positive. A negative times a positive divided by a positive is negative overall. And then you've got positive times a positive divided by a negative, that's positive. Okay, so overall for the intervals, I'm looking for the negative parts. So here's where I have negative values, and here's where I have negative values, which will match my graph. This is negative infinity to negative 2. Closed or for parentheses, union 0, comma 2. This is the answer we're looking for. All right, third problem. Here we go. This one is a little bit different, and I'm only going to do interval notation on this particular problem. Okay, please notice that I'm not equal to 0, I'm equal to 3, which makes things more difficult. It's much better to just know where am I positive versus negative. That's the whole point of the table we just dealt with. So I'm going to subtract 3 from both sides, and I'm going to get 2x minus 7 over x minus 5, subtract 3, and I want to know where that is less than or equal to 0. Now the problem is that we've only been dealing this whole unit with all fractions. Well, with single fractions. And so this is 3 over 1. And so I'm going to give it a new denominator by multiplying the top and bottom by x minus 5. And so I've got 2x minus 7 over x minus 5. If I distribute this, I get negative 3x plus 15 over x minus 5. And again, I'm looking for where this is equal to 0 or less than 0. If I continue on, I get negative x plus 8 over x minus 5 is less than or equal to 0. Okay? This is what we're going to use to evaluate things. Okay? So over here, I have an interval land. I have a negative x plus 8 and an x minus 5. Now, where does negative x plus 8 equal 0? Well, add x to both sides, and I get 8. All right? There's 8. Now, this is in the numerator, and so if I equal 8, I equal 0. And guess what? I want to equal 0, so I'm going to put that as a closed dot. Where does x minus 5 equal 0? Well, that's at x equals 5. So 5 is smaller than 8, so I'll put it there. That's in the denominator. It's never going to equal 0. And so we put that as an open circle. And now we have 1, 2, 3 intervals. And we're going to test points in all of those intervals. Hey, I'm going to test 0, like 6, and 10. Those are numbers in the intervals that we're going to plug in. All right, let's plug in 0. 0 times negative 1 plus 8 is a positive value. Let's plug in 6, right? 6 is the next one. If I do negative 6 plus 8, I get a 2. And then I'm going to plug in this 10 over here in the third interval. Negative 10 plus 8 is negative 2. Fantastic. Now let's go to x minus 5. 0 minus 5, because I'm plugging in a 0 here, is negative. Let's plug in 6 next. 6 minus 5 is a positive value. And then finally, let's plug in 10. 10 minus 5 is a positive value. All right, so overall, a positive divided by a negative is a negative. A positive divided by a positive is a positive. And a negative divided by a positive is a negative. What do I care about? I care about where things are less than or equal to 0. So I want the negative stuff. So there's negative, and there's negative. Okay? So I'm going to go from negative infinity to 5. This is an open circle, so I use parentheses. Union, because this is a closed circle, I have a square bracket, 8, and I'm going all the way to positive infinity. And that's my answer. Okay, this concludes the inequalities section of your notes. So fill those out, make sure you understand them, and we'll proceed on to the second part later.